Hello, everyone, and welcome to today's lesson on the relational algebra. The relational algebra is a branch of mathematics, and it happens to be the foundation of the SQL language that we will be learning in this course. Basically, the relational algebra it's math that operates against sets of numbers. Imagine a matrix filled with numbers, rows and columns, like a table, right? Filled with numbers. I can do relational algebra operations against that set of numbers. And the reason why we go through this is because this is where SQL has its origins. So the relational algebra, it's not complicated. It's a lot like high school algebra. When you were in high school and you learned algebra, you learned to do operations with numbers and variables, like the quadratic formula, or just looking at this. I've got 3x squared minus 2xy plus c. I'm doing an operation here with numbers and variables. Now, in the relational algebra, the variables are relations. And what's a relation? It's a table. What can I do with my tables? I can do relational algebra operations like union, intersection, difference, selection, projection, product, and join. So these relational algebra operations were built into the SQL language. The operations that I do in relational algebra are set operations that work against an entire set of data all at the same time. In a relational database, I store my data in tables or relations. And I can do these operations against the tables in my database. So let's look at a couple of examples here. I can take two tables, C and S, two different tables, and I can do operations like union those two tables together. So what is a C union S? A union of this table C and this table S. The union is going to give me all the elements in C or in S or in both. That's what a union does. And intersection gives me the set of all the elements in C and S. And the difference is the opposite of that. It'll give me all the elements that are in C but not in S. So this is kind of what the relational algebra looks like. Here's an example of a union then. So I've got two tables. Here's table C and table S. And this table's got a customer ID, customer name, contact name, address, city, zip code, and country. Now, I can union table C and table S in relational algebra, and that operation is going to yield another relation, which is the union of these two tables. So I get all the data from both tables unioned together. Another relational algebra operation is called projection. What's a projection? It's a relational algebra operation that allows me to get a subset of columns from a relation. So in this case, I've got a table C, a relation, and I've got these columns: customer ID, name, contact name, address, city, postal code, and country. If I do a projection operation, I can do like this: a projection operation against the relation C, where I'm grabbing the columns customer ID, customer name, and city. So the relational algebra operation of projection will grab me those three columns. There's another relational operation called selection. This allows me to produce a new relation that is a subset of rows from a table based on a condition. So in this case, I can establish a condition where country equals Mexico against table C, and I do a selection operation, and that will yield two of these three rows. It's yielding only those two rows where the country, the value in the column country, is equal to Mexico, because that's the condition on my selection relational algebra operation. So I can do another relational algebra operation called a product. Basically, a product is the result of a multiplication. And a product will take one table, like table C, times another table, like table O. And what it does is it combines every row of one table with every row of another table. What I do get from that operation can easily look meaningless because it's taken customer data, customer ID, customer name, and order data, order ID, customer ID, order total, and it's combined every row from one table with every row from the other table, and it looks pretty meaningless, right? But that's the way a product works, the product operation in relational algebra. Now, I've highlighted these two rows because these two rows in the answer set of my product operation, they show that this customer ID from the customer table is equal to the customer ID from the order table. So this data is more meaningful than the next few rows in the product where the customer ID here is not equal to the customer ID here. It's meaningless data. So what's the point of a product? Well, it allows me to do a natural join where I can take this table times this table and match them together on a common attribute. So my natural join allows me to join table C with table O, where the customer ID from C is equal to the customer ID from O. That's called a natural join. It's one of the operations that I can do in relational algebra. Now, this covers pretty much the basic stuff in relational algebra. Why do we go through this? I want you to understand two things. That when E.F. Codd invented the relational database concept, he based the relational database operations on this branch of mathematics called relational algebra. And the SQL language that we're going to be learning in this course is a direct implementation of relational algebra operations. So the things that we've just looked on, the slides that I've just shown you, illustrate how the relational algebra operations directly translate into SQL operations that we're going to be learning in the next several lectures. That's it for relational algebra. Thank you.